we're going to take a look at inverse normal. So in the last video, we did normal CDF, which basically takes a data point, a range, and gives us a probability. Now we're basically taking a probability, going backwards and finding the data point. So let's take a look at this example in order to understand what I'm talking about. So we have a mean of 50 and a standard deviation of 6, doesn't matter what we're talking about. And I'm asked, what is the largest value for the bottom 2.5%? So if I take a look at my normal distribution, this is where we started. We estimated each of these intervals within a deviation. So our mean in this example is 50. So that means within one standard deviation is 56, and within two standard deviations is 62, and within three standard deviations is 68. And then if I go the other way, 44 and 38 and then 32. Okay, now the problem says that I am looking at the bottom 2.5%. Well, the bottom would be the left-hand side. We would say the left tail of this. So the left tail would be over here. And the bottom 2.5% would be all this area right here. And I want to know, well, what data point does that give me? And that gives me the largest value for the bottom is 38. That's the largest value for the bottom 2.5%. So let's go on and let's take a look at another example to help clarify this maybe even a little bit more. So same setup. We have 50, 56, and what was it? 62, 68. And I'll just go a little bit over here. Okay, so what is the smallest value for the top 16%? Well, the top 16%, if I started adding up these, would be all the way to here. And the top 16%, that's going to be the right tail, which is going to be over here to the right, because that's the highest values, all the way over here. Now it asks, what's the smallest value that could be? Well, 56. Of course, this is all hitting right on each of these standard deviations on our estimate here. But what if it's not so cut and dry? So let's take a look at a situation like that. We won't need this graph anymore. I'll sketch it out if we need it. So a store found that the average customer buys $170 worth of groceries with a standard deviation of $13. And then we have three questions here. What is the most? So that's the highest amount. That the cheapest 25% spend. So if we're taking a look at our distribution, there's our distribution. Here's our mean in the middle, and I want not necessarily the cheapskates, but the people who don't need to spend as much. So they're over here on the left because they aren't spending as much as the average person. So they're down here, and this would be the left tail end. But what I'm looking for is the highest amount that bottom 25 would possibly spend. So that's left tail end. So I'm going to go to my calculator, and it's going to be similar on the TI. I meant to delete all. We're going to go to our statistics, and we're going to go to our distribution. So on the TI, that's second distribution. I'll write that down over here, second. And you're going to find the distribution button. And then under that, you're going to find inverse normal. Or your calculator might say inverse norm. Same thing. So that's what I'm going to find. I went to my statistics menu. I went going to distribution. I'm going to normal. And then I want this one, inverse norm, INVN, inverse norm. And the data type needs to be variable if your calculator gives you that option. Your tail in this case is going to be left, and the area under the curve is that 25%, but I'm going to put it in as a decimal 0.25. I need to tell it my standard deviation, which is $13, and my mean is 170. And at that point, I'm just going to press enter, and it gives me 161. So $161 is the most that these people would spend. What is the least that the biggest 20% of spenders would spend? So here's our distribution, a sketch of it. And now we're over here on the right because we're talking about the biggest spenders. And the biggest spenders are over here. And I want to know what's the least that they'll spend. What's this value, the smallest amount that these guys would spend? So this is our right tail end. So I'm going to go back to my distribution, and I'm just going to change a little few things. First of all, I want the right tail end, so right, and my area is now 0.2. Okay, so notice what I did there. This became 0.2, and this became 0.25 when I put it into my calculator. And I'm just going to press enter, and about $81. So the least that the big spenders will spend is about $81. What range do the average? Now this is a clever way of saying the middle. Okay, the middle 15% spend. So if I take a look at my distribution, what I'm wondering is right here in the middle are our average spenders, and what range do they spend? They're right here centered. What are they going to spend? Now this is going to give me, unlike these two, this is going to give me two values. So I'm going to go back, and I'm not going to change much of this information. Just now when I go to my tail, I don't want left or right. I want the center, central. And my area is 0.15. And there we go, about $68 to $72. $172. That is what the middle 15% spend range, only a $4 range there. That's okay. All right, let's take a look at one more example then. It's not that much different than doing the normal CDFs. It's the same basic idea. We basically put in our mean. Here's our mean. And here's our standard deviation. And we're going to let the calculator do most of the heavy lifting for us. So what is the largest shoe that those with the smallest foot, 10% foot size buy? So a big trick is even understanding my gibberish right here, but what the question is asking. So it is essential kind of take that moment, think about it. So the average shoe size that Super Shoe sells is 9.5. So 9.5 is in the middle. That's the average with a standard deviation of shoe size of 1.5. Now we're going to want to bring in some context. Shoe sizes go in increments of a half, right? So a shoe size of 9.1 is not possible. So we're going to want to bring the context into this. Okay, so we're going to plug in this information. So we're going back into our distribution. Our standard deviation is 1.5, and our mean is 9.5. And we want the largest shoe that those with the smallest feet buy. Well, that'll be over here. These are the small feet people, and we want to know what's this value right here. What's the largest shoe that they might buy? So our area is 0.1. We want the smallest 10%, and our tail is left. We want the left side. All right, and that gives us 7.757. So I need, because shoe sizes come in half increments, so the largest that they would buy is 7.5. What's the range of shoe size that the middle 35% buy? The middle 35% buy. So we're talking about those averages, the average person. They're in here in the middle. So this is our central. And basically what this 35%, 0.35 when I put it in the calculator, that's giving us the area under this curve. So we want to know, well, what is the two values that it's stuck between? So we go to our stats, and our tail is going to be central, and our area is 0.35, and the standard deviation mean have not changed, and we get 8.8. So again, we're going to bring in the context. You can't get an 8.8 size shoe. So we might want to argue, well, is that closer to a size 9 or closer to a size 8.5? And I actually would say that's closer to a size 9. So this is a size 9 to 10. So 9 to 10. Of course, not every problem is going to bring, like, this is kind of a complicated rounding situation where you only have half sizes. But most of the time you're talking about money, in which case you would round to the nearest cent. But you do whatever the directions tell you. So the last question, and then we'll wrap up. So what's the smallest shoe size that those with the biggest 40% feet buy? So we're talking about Bigfoot over here. These are the Bigfoots. And we want to know what's their smallest foot size. What's that? So that is our right tail end. So we go over here. We're going to go up to tail, and we're going to switch that to right. And our area is 40%, so 0.4. And nothing else has changed. And 9.88, so about a size 10 shoe is the smallest that they would buy. Again, this example was mainly talking about a weird circumstance where you only have half sizes, but the general gist is you're going to take, unless you have a weird situation, you're going to take whatever number that gives you and round, according to the context of the problem.